Okay, here we are. We are in version 0.9 of our app, and I really, really want to apologise at how we left last version 0.8. Did I say we're in 0.9? We are in 0.9. Version 0.8. Last version, I was just writing the release notes here, right? And I was like, we squashed that bug when you drew a game and then you started a new session, the game would not reset properly. So we did that, and I was like, what did we do last version? We added the logic for computer turns. That was it, and we didn't even get it working. Which was a really bad way to end that version. So today, what we're going to do is instantly, we're going to fix that and we're going to get it working. So there are two things that I need to change in my code to get the computer turns working. As soon as I finished that last version, I had a little look through the code and I think I found the culprits. So if we go to the player class and go down to the player file and go down to our computer class, what I've done is I've said player.init, but the syntax is super.init. So I've commented it what it should be here. So let's just remove that comment. And instead of saying player.init, we need to initialize the super class, which we are telling Python is player because we put it in the brackets up here. So we're saying initialize that super class, the player class, and the computer will be just like a player. It will have everything that a player has, but it will also have this stuff as well. Okay, so this is called inheritance when we're working with classes, and it's a way that you can kind of make some classes more complex than others, right? So you might have like a human class, and then you might then have like you might then do like by profession, so like firefighter, and they would inherit the human class, and they'd have special things that a firefighter can do that like a teacher wouldn't be able to do. So inheritance, just like here, where we have the player and then the computer needs to be exactly like the player, but build off of that. So we got the super there. We also need to jump into main. Sorry, that was a real waffle. And come down to, where have I put it? In computer turn. Okay. Now in computer turn here, I've just said grid, and that is not what we want. We want to add in. It's even underlined, and I didn't even notice. Self.gameboard.grid. Okay, and you can see this angry comment I've put there at myself. So we're passing in when we say players 1 take turn, we're saying here's the grid from the game board, and that should work. So let's test this and see if those fateful words are going to backfire on me. So I'm going to tick computer opponent. I'm going to pop in Bob, and we're going to start, and it is the computer's turn apparently. Now this is an issue. So Bob's gone, but it was the computer's turn, and we'll get to that in a second. Now I should be able to go, and now the computer's instantly gone. Can you see that? And then I should be able to go again. So if I go here, then the computer's gone there. Oh goodness! Now I'm going to have to go here. Oh no, it's too clever. Okay, fantastic. And we got to the end here, and it hit an error, but that's all good, that's all working. Now, what's happening is, if the computer goes first, nothing's actually happening because it relies on this, this next turn function to run in order to actually run. So what we're going to do is we are going to take this bit of code from our next turn function, and we are going to make the name, I'm not happy with the name. I'm not happy with it, but we're going to make a turn function, okay? And this is going to be a single turn. So we've got next turn, so that we've got change turn, which when it is the next turn, we have to change the turn first, and then we go through the players and we change the statuses of them. Okay. When we actually want a turn to happen, we literally just want this, right? So I'm going to take these lines here. If self.player.names1 get equals computer down to self.computerTurn, I'm going to take that, I'm going to put it inside turn. Ooh. Oh no, I pressed Control C instead of Control V. Let's try that again. Put it inside turn here. Now what we're going to do is down here, we're just going to say turn, self.turn. Okay. Now, when we first start the game, we also need to run turn, because if it's the computer's turn first, then we need to be like, do the turn. Because this next turn is only run at the end of clicked. If game over is not equal false, next turn. So we need something to kind of kick this off. So we, down here, we have a new game. Oh my god, the scroll. We have a new game, don't we? New game. Here we go. Fantastic. So if self.gameover equals true, we reset the board, we get the first turn, we set the player turns, we say self.gameover equals false, and then what we're going to say is if the game over is true, we reset, set game over to false, and then we're going to say self.turn. Okay, and what this is essentially going to do is it's just going to make sure that if the computers go first, it's going to take its turn. So now we should be able to run this. I think it's random, so I think we might have to run it a few times to check it's working. But if I go Bob start, okay, you can see the computer's already gone now. It's put its naught there, and it is now my turn. Now the computer is deadly when it goes first because we've programmed it to like an algorithm that is literally bulletproof. And so, but one thing we haven't done is we've only got it checking for rows. We've not got it checking for columns. So if I know that it's going to search for its corners going across the rows and then down. So I know the next thing I place, it's going to go in this top right hand corner if I don't go there. Let's just test that. So I'm going to go here. Oh, it went in the bottom right. Okay, interesting. Okay, so I'm going to go here, and you can see it's gone in the top right and it's in the bottom right. Now, its next move should be the computer. If it's playing intelligently and if we've programmed it well, the computer should go here, okay? But that's not what it's going to do. I don't know what it's going to do, but let's just go in the middle and see where it goes. Okay, it doesn't actually go anywhere. Okay, so we'd gone in all the corners, and it didn't like the fact that it couldn't go anywhere. Now it could go here. I guess if it's got nowhere to go, it's struggling. So let's go to our computer class and let's come down here. So in turn 1 we find any corner. In turn 2 we find any corner, either the opposite corner or we just find any corner. In turn 3, oh, the opposite corner. That's what it was trying to do. It's going in the opposite corner. Okay, yeah. So it wasn't going there. It was going there. Okay, that's fine. And then in turn 3, I said not finished here. Oh yeah, because we've not implemented the column checks and the diagonal checks. So what we should do is we should do that now. We've already written functions in GameBoard in order to check the columns and to check the diagonals. So we're just going to take this and change it to what we want it to do. So I'm going to take this check columns function. I'm going to copy it and I'm going to come over to player. And I'm just going to paste it into here. So let's go up just before turn 1. And let's paste it here. I'm also going to hold down Control, press K and 2 to close everything up, just so it's a little bit more compact. And here we go. So how are we going to change this? Well, we need to be given the grid. So our check columns function is going to have the self and it's going to have the grid. Our test column, we're not going to have that. We're going to say for x in range. Now we don't want self.board size. We probably want grid, length of grid, because grid is a series of rows, right? Length of grid. And then we're going to say for row in self.grid for oh, okay, so this is column. So for column, let's just stick to the number 3. There's nothing wrong with number 3. For column in range 3, okay? And then we're going to say for row in grid, we're going to say our space is equal to row at this column, whatever column number is. So we're going to start at 0, go 1, 2. And we're going to say row x dot get context. We're not saying x though, we're saying row column dot get contents, okay? And we need to be keeping count just like we did in all the others. So if I go to turn 1, I think we did it in. No, not turn 1. If we go to turn 2. No, did we do it in turn 3 then? We were keeping track of something, right? Oh, okay, I was doing it in a separate function. So check 2 and blank, we have our blank spaces. So here we're checking for blank spaces. So we want to say exactly this. Where is it? If space dot blank, blanks dot append space. So I'm going to take this code here, I'm going to copy it, I'm going to come down here, so for row in grid, space equals row column dot get contents. We're then going to say if space is blank, blanks dot append space, and we can get rid of this test column equals grid column. We're going to change this grid column to blanks. Okay, and then we're just going to do exactly the same. So we've got if length of blanks equals 1, symbol count equals 0. And then what does this do? For space in row, if space.getContents equals symbol count plus 1. If symbol count is equal to 2, return blank 0. Okay, yeah, so this bit of code here checks through those spaces and it checks to see whether it's our symbol. And if it is our symbol, then we go there. So if we come down here and paste this in, so where does this want to go? This wants to go back once we've done the here. So outside of this for loop, but inside of this for loop. So if the length of our blanks is equal, oh no, didn't want to do that. If length of our blank is equal to 1, our symbol count equals 0. For space in row, we want to say we don't know what row is. We want to say for space in grid. Wait, what are we doing here? What are we doing? I've lost the plot here. Check columns. So we're going through the columns, and if there is a blank one in there, we are putting it into this blanks array. If there's only one in the blanks array, then we know we've got one empty spot in the thing. And then what we need to do is we need to go back through it. So we need to do, say, for row in grid. So for row in grid. And then we're going to say space equals row column. So exactly the same again. Space equals this. If space.getContents equals symbol. Actually, we're doing this twice, aren't we? This is silly. This is really silly. So we can be doing this up here. Let's take this. So we've got if space.is blank, blanks.append space. If space.getContents equals symbol count plus equals 1. Let's take symbol count and let's pop it up here next to blanks, and we can get rid of this. So now we're just saying if the length of blanks equals 1 and our symbol count is equal to 2, so we've got 2 of our symbol in there and we've got 1 blank space, then return that blank space, okay, that will be stored in blanks. Now, what is the symbol? It is our symbol. So it is self dot, oh, we get given the symbol? Yeah, let's say we get given the symbol. So we'll just do it exactly the same as that one. So this should just work. So if we come down to turn 3, we get opponent symbol, check for 2 in a blank. Go in a free. Oh, maybe it's turn 4. If the 2x place in a line. If the 2 oh, in a line. Yeah, okay. So we're going to say check columns here. What did I say? Check for 2 in a blank. I'm just going to change this to check rows. That makes more sense. Yeah, that makes much more sense. So I'm going to say check rows, check columns, and check for 2 in a blank. It's too generic now because we've got having to do the rows, columns, and diagonals. Check rows, and here check rows. Okay, fantastic. So now what we're going to do is we're going to check to see, so if winning space does not equal false, return winning space. We need to do this a series of times for each of the different functions. So I think what we're going to do is we're going to write another method, and this will be quite helpful. Okay, so we're going to write a check position method. Check what is it? Def check position, and we're going to be given a self and a function. Okay, and what we're going to do is we're going to have this syntax here. So we're going to do, I guess we need to be past the grid as well. self, a grid, and the function. So I'm going to take all of this code, this winning space equals if return. I'll take all of this, I'm going to paste it here. Okay. If winning space does not equal false, return winning space. Do I want to do this? Do I want to do this? Do I want to do this? Yeah. Maybe this is more hassle than it's worth, actually. I don't like it. As I'm thinking about it, I don't like it. So we're going to just do this, but we're going to do the same thing, but we're going to check for the columns, right? So if winning space does not equal false, we return the winning space. If, and actually, let's do, let's just take this whole thing. Winning space, no, yeah, okay. So let's say winning row space. Oh God. And then we're going to have winning row space here, and we're going to return winning row space. And then we're going to do exactly the same for the column. So I'm going to copy this. I'm going to come down here, and I'm going to say winning column space equals self.check columns. And we're going to pass in the grid, and we're going to pass in self.getSymbol. Yeah, fantastic. And then we will do one more. So we will say winning diagonal space. Oh, space is equal to self.check diagonals. Pass it the grid. Pass it self.getSymbol. No, not get status. Get symbol. Symbol. Oh dear, what is happening with my hands? It's too cold in here. I can't type properly. Okay, so then we've not done check diagonals. Don't worry, we're going to implement that. So then we can say if winning. So if we don't have a winning row space, if winning column space, I've spelt column wrong. That's embarrassing. If winning column space is equal does not equal false. False. Then we are going to return winning column space. And lastly, if winning diagonal space, let's just copy this, save writing it out, does not equal false. Then we are going to return winning diagonal space. Make sense? Yeah? So we check to see whether there's a space we can go in that will win the game in each row. And if there is, then we'll go there. We then check the columns to see if there's a space that we can go in that will win the game in each column. If there is, but there's not one in the rows, we'll go in the column. And then we'll check the diagonals last of all. Okay, this is good. Now we just need to implement that check diagonal. So we're just going to steal this from the game board. I'm going to steal both check diagonal and check diagonals. I'm going to just copy these straight from the game board, and we're going to go into our computer, and we are going to implement this. So let's minimize this, minimize that. Now this is going to take a little bit of testing once we've implemented it, because obviously we need to test if the computer actually wins in these certain conditions. We're gonna have to do a little bit of testing, but that should be fine. So let's start with our check diagonal function. So just like the others, it wants the grid and a symbol. Okay, so we're going to give it the grid, and we're going to give it a symbol. Oh wait, hang on. This, because it's diagonal, it needs a start x and an increment. That's fine. We can leave that there, and we're going to have a symbol. Grid symbol, start x, increment. Okay. So we're going to go through the row in self.grid, and then we're going to ask the same questions that we're asking in check columns, right? We want to know, is the space blank? And we want to know, are there any symbols there? So I'm going to take blanks and symbol count and copy that. And for each row in our grid, we'll paste that. Oh, no, wait. No, this is one for loop, isn't it? Yeah, so we want to paste that here. Let's get rid of grid diagonal. That can go. Symbol count equals 0. So then what we're going to do is we're going to take this whole thing here inside this for loop. There's probably a very clever way that I can do this that means I don't have to like check rows, check columns, and check diagonals. Could all be one function if I was really clever. But hey, it is what it is. So I'm going to take all of this and I'm just going to paste it. We've got symbol equals row x dot get contents. I'm going to leave that where that is. X plus equals. Okay, so let's just get rid of grid diagonal dot append and paste this in here. So space equals row column dot get context row x dot get contents. Okay, cool. So this is kind of the same thing, right? So we can replace this with x, this column variable, and we can just get rid of symbol because it's exactly the same. We're going to stick with space because all of our code down here is done for space. So we're going through row, not in self.grid, but for row in grid, we're going to pass in the grid. And our space is going to be row at position x, and then x is going to increase. So down here, we've got this little x plus equals increment. So it's going to either increase or decrease as we go through the loop. So this is indented weird. Let's pull this back, and then let's pull this whole thing back. Okay, yeah. So this. Okay, this if statement here, this if len blanks, this needs to be outside the for loop, but this x plus equals increment, this needs to be inside the for loop. So I'm going to cut this and I'm going to paste it down here. Okay, so it's actually in the loop. So for each row in our grid, we're going to look at a specific x coordinate. So we're going to start in the top left when x is 0, then we're going to look at the middle when x is 1 and the row is 1, and then the row is going to come 2 and x is going to come 2. And then we can use this again, but we can work backwards using this syntax up here. So now all I need to do is get rid of this if statement. So I'm going to get rid of this. We want to keep the return false though, because if there's nothing there, then we want to return false. Okay. So if the length of our blanks is 1 and our symbol count is 2, then we know that we've got 2 of our things in this row and we've got 1 blank space to go in. Otherwise, there's not a space to go there, and we'll just go there. So this is how we check a diagonal. So, and this returns a thing here. So I guess we don't want the check diagonals. We just want these two lines here from this. So I'm going to cut this because when we wrote this for the game board, we were just returning Boolean values, so either true or false, like it was there or it wasn't. Whereas here, we're actually returning a space so it can be clicked by the computer, and so we can't just say diagonal 1 or diagonal 2, and so it doesn't really lend themselves to being called in a single function. So let's cut them, get rid of check diagonals. Okay, we're so close to having this. We're so close. This is great. Okay. So our winning row space, our winning column space, our winning diagonal space is going to be, I'm going to call this winning forward diagonal space. And we're going to set that equal to self.checkDiagonals. I'm going to cut this and I'm going to paste it where this was. We want the grid and we also want self.getSymbol. So I guess I'll just get rid of this bit, paste this in. I didn't think about that. Okay, 0 and 1 are the numbers we want. So I'm going to get rid of this grid, get symbol. We're going to put in 0 and we're going to put in 1. And am I missing a bracket? No. Okay, check diagonal. Is that what we're asking for? Grid, symbol, start x, increment. Start x 0, increment of 1. Fantastic. And then what we're going to do is we're just going to copy this line, paste it down here. We're going to have winning backward diagonal space. So like backward, forward, something like that. One's 1 and one's the other. And instead of 0 and 1, we're going to have 2 and minus 1. Okay, so that's going to check the backwards diagonal, just doing exactly the same but different coordinates in that grid. We can get rid of these diagonal 1 and diagonal 2 lines now. And we can just add a final if statement to our thing. So I need to update winning diagonal space with winning forward diagonal space. Here we go. And I need to just copy this paste it below. This if statement, I'm sure there's a better way of writing it, but it's okay. Being inefficient is okay. That's fine. We're here to ultimately enjoy ourselves and learn something, and no one's judging. Okay, fantastic. So this checks for a winning space. Yeah? So what I'm feeling is it would be good if we just wrap this in a function, right? Because it's a little bit much. So I want to kind of close up check diagonal, check columns, and I want to make a function because we might need to use these in other terms, and I don't want to duplicate this huge block of code. So I'm going to say def check for winning space. We want to be passed the grid. I think that's it. Oh, the self, obviously. Do we want to be passed the grid? Anything else? No? Okay, fab. So I'm going to take all of this and I'm going to cut it. Bosh. And we're going to go into check for winning space and I'm going to paste it. I need to put a colon there. Okay. Right at the end of this if statement, else, if none of those happen, then we're just going to return false. Okay, so our check for winning space is going to check the rows, it's going to check the columns, it's going to check the diagonal, it's going to check the diagonal. Okay, and then if this isn't false, it's going to return that. If this isn't false, it's going to return that. Blah 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 blah. If all of those are false, then we will just return false. Okay, so down here, what we're going to say is we are going to say winning space equals self.check check for winning space. We're going to pass it the grid, and we're going to say if our winning space does not equal false, we'll return that winning space. Winning space. There we go. Okay, so this is going to do all of this code here. Okay. And that's all wrapped up nicely and kind of out of our brain. So in turn 3, we check for a winning space. If there's no winning space, then we look for the opponent symbol and we check the winning space. Ooh. Okay. So now what we need to do is I'll check for winning space. We need to abstract this so it can be given a symbol. So we're going to give it self.getSymbol. And we need to now come up to check for winning space. And instead of here, where we're saying self.getSymbol, 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 that's the symbol we're kind of checking to see whether it's in the spaces or not. We're going to replace this. We're going to add a parameter in here. We're going to add in symbol. And we're just going to replace self.getSymbol with symbol. And I will copy this and just paste it over these to quickly get rid of them. And now this will allow us to run this function not only to check for winning spaces, but to check for spaces that we need to defend against. So I'm going to come down here and we're going to say opponent symbol equals self.getOpponent symbol. And then our defending space is going to equal this self.check for winning space. So instead of self.check rows, self.check for winning space. And we're going to pass in that opponent symbol. So we first check for a winning space with us, and then we find, actually, is there somewhere we need to be defending? If we can't win the game, is there some way that we need to defend from losing the game? So we're going to check for those spaces, and if there is a space that we can defend, great, let's go there. Otherwise, we're going to say return self.turn1. Okay. Now, on turn 3, if the computer didn't go first, if Bob went first, if Bob went in the corner, computer goes in the corner, Bob goes in the corner, computer goes in the corner on turn 2, that means on turn 3, it's possible that there will be no spare corner to go into. Okay, so what I want to do is move 1, go in a corner, right? That's fine. That's absolutely fine. What I want is I want a method that will just, if there's nowhere to go, if there's no corner to go in, if there's no like place to defend, no place to win, I just want it to pick a square, right? It's got this kind of like method that it's going through, but if none of that works, I just want it to go somewhere, because at the moment we're getting this error behind me because it's checking for a corner and it can't find a corner, and it's like, well, all you told me to do is look for a corner on this turn and I can't find one. And so what we need to do is we need to have like a fail safe that if it can't find what it's looking for, the very last thing it does, it just finds a free space and goes there. So let's write a function for find a free space. So def find, can you believe we're still programming this computer brain? I thought this would be done and dusted yesterday. Find free space. We pass in the self. We also pass in the grid. And we are going to say for row in grid, for space in row. What are we checking for? If, what is it? Space dot is blank. If space dot is blank, let's copy that. If space dot is blank, return space. Okay, now we don't have to, there will be a blank space, right? If it's the computer's turn, it has to have a space. I guess just as a failsafe, we'll just put a return false here if there's no free space, but technically the computer shouldn't be having a turn if the game is finished. Okay, so there should either be a free space for the computer to go in, or the computer, it shouldn't be running this code at all. It shouldn't have got here. But we'll put a return false in just in case. So now down here, what we'll do is we are returning self.term1. We don't want to do that because there might not be a free corner. So what we're going to do is we are going to say corner equals self.term1 and pass in the grid. And we're going to say if corner, this if statement is like 100 times in this code. If corner does not equal false, then we're going to return corner. And am I returning false on term 1? Return square, no. So at the end of this for loop in term 1, I need to return false. If we don't find a corner, we're going to return false. Okay. If corner equals false, it does not equal false, return corner. And then what we're going to say is we're going to say empty space equals self.find free space. Should I call this variable free space? Yeah, I absolutely should. Free space equals self.find free space. We'll pass in the grid, and then we will say exactly the same thing. If free space does not equal false, we will return that free space. I guess actually we technically don't need to do this check because free space is always going to return something. So yeah, maybe it could be argued that we could just say return free space. And if that causes a problem, then there's some issue further on with our code. So we can get rid of this return self.turn1 grid. Now I'm not happy with calling turn 1 in turn 3. So what I want to do is I want to take all of the code. I want to take all of the code for turn 1 and I want to cut it. I'm going to take all of this and I'm going to make a function, a method, def check corners. Self, grid. Oh, this computer class. I'm glad we didn't put this all in the player class. So we're going to do all of that in check corners, and then we're literally going to say turn 1 corner equals check corners, self.check corners. Not columns, check corners. I'm going to pass in the grid, and we're going to return that corner. Fantastic. So now down here in turn 2, when we say return self.turn 1, we're actually going to say return self.check corner. And this just makes it read a bit better, right? So instead of like do turn 1, it's like, oh, else check the corner. So let's just take this else, because this is like the algorithm that I got. It's in the description, that computer science for fun algorithm. So if the other player did not go there, then go in the opposite corner to move 1. So that's what all of that does. That's what all of this does. Else we go in a free corner. So return self.check corner. That's fine. So on turn 2, we're guaranteed to have a free corner. Even if the other player went first, there will be 1 free corner. Okay. On turn 3, we're not guaranteed to have a free corner. And so we are going to do, we're going to find a free space if there's no corner available. If there's no place to win, no place to defend, we're just going to check the corners and then find a free space if none of them are viable. Turn 4 is going to be turn 3. That's fine. I'm happy with that because it's a carbon copy. That just does it. That just works. Just works. I feel like I've missed something out of brackets here. Self.check corner. Okay, yeah. Self.check corner needs the grid. Check corners. And it needs to be passed in the grid. It was in the back of my mind. It was like, you've forgotten something. You've forgotten something. Okay. This looks fine. I think we're there, you know. I think we've got it. And then turn 5 for okay. So this is our algorithm, go in the free space. So here we can actually get rid of this and we can say self.check find check find. Oh dear, so inconsistent. We're going to find the free space and we're going to return whatever that gets, okay? So we're going to find that free space in turn 5 and we're going to go there if we ever get round to that. When we take our turn, we are simply just counting how many turns we've had, and depending on what turn it is, we're going to do this step of the algorithm. Okay, so let's run this and see if we have a actual computer taking turns and going against us. So I'm going to be Bob again. And let's see if it can win diagonally, right? So it's my turn first, okay. We know the computer is probably going to go in the top left if I leave that empty. So what I'm going to do is I'm going to go right here. Okay, so it's gone in the top left. It's then going to look to go in the bottom right. So I'm going to go, where should I go? I'm going to go down at the bottom here. Okay, it's gone in the bottom right. Now it should, if our algorithm works, it should prioritize going here to win the game rather than going in another corner. So I'm going to go here on the left. And it's thrown an error. Oh no. In check columns, if space dot is blank, string object has no attribute is blank. Okay, line 80 in check columns. So let's go up to line 80. Man, we've written a lot of code for this. A lot of it's duplicated. Space equals row column dot get contents. I don't need to get contents, do I? No, what I need to say is, okay, space is equal to row at column. So this here, get contents, needs to go in check columns. So space is our row at the column position. Have I done the same with rows? No, I've done rows is correct. My space is just in the for loop. I'm looping through. What about my diagonals? Space equals row at position X. Okay. Simple bug fixed. Okay, I was getting their symbol, but I don't need to. I only need to do that here. I need the actual space itself, the space class, with all of its properties and methods, so I can check to see whether it's blank, and I can actually append that actual space that we can then pass on to be clicked if we need to. So let's run this again. I do really enjoy using this AI that we've built. It's really satisfying having built this to be able to use it. Okay, the computer's gone in the top right hand corner. Okay, so I'm going to go in this space here and it's going to go down to the bottom right. There we go. It is kind of predictable, right, when you've built this thing, because you know exactly what it's programmed to do. Now, if I go just in top right, it's going to go here and it wins. Great. So it found that diagonal spot and it went there, which is fantastic. So let's do a rematch. So now it's my turn first. Now I'm going to try and win, and I'm going to see if the computer will defend against me successfully. So I'm going to take the computer strategy, and I'm going to go in the top right. And now what I'm going to do is I'm going to go in the bottom right. Okay, that was bad. That was really bad. what it should have done is it should have gone in the middle there, right? It should have checked to see if there was a space it could defend, and went there. Instead, it just went in the middle. It like looked for a free space. So that was on turn 2. So let's have a look at our logic for turn 2 and see what we're doing. Opposite corner. If the other player did not go there, then go in the opposite corner to move 1. Else go in a free corner. Okay, so interesting. Why did it go there? That's really bizarre because we're telling it in turn 2. It like if you can't find, like, this is all for the opposite corner, right? If you we work out where the opposite corner was, and then we go there. If it's blank, but it wasn't blank. No, it was blank. Opposite corner. Because turn 1, it didn't go in the top left corner, did it? Oh, check corners is appending this to, and we're running this elsewhere. That could be an issue. That could be an issue. But, okay, either way, it works. So I can press X here and I win. Let's do another match. Okay, I've balked the game here. Let's refresh this. Okay, here we go. So computer opponent, Bob. So let's try this again. So the computer's started here. If we go in the opposite corner, it just finds another corner. Okay, fantastic. In turn 3, it should be looking for a winning space. So this is a winning space here. Okay, now I'm going to have to go there and block it. Now it's going in another available corner. So in turn 3, it if it didn't have a winning space, it had no space to defend, so then it went in a corner. Now, if I go here at the bottom, the computer really needs to block me, okay? If it's picking a space at random, it's going through them like this, 1, 2, 3, 4, and when it gets to this blank one, it will go there. So if it gets to just finding a random one, it's going to go here. However, if it's actually being clever and our algorithm's working, it should go here to prevent us from winning. So if I click here, no, it's being done. And so something's not working with our check for winning space. Okay, because it's not finding this properly. Oh no, it checked. The computer beat me. It is working. It just beat me. I just saw the winner and I was like, oh wait, hang on, I lost. Oh yeah, I did lose. Okay. Let's. It's really difficult to test when I've built this AI too good. So let's try this again. I've gone here. The computer's gone there, which is really bizarre. I'm really confused as to why it goes there. But if I go like down here, okay, it didn't like that at all, did it? String object has no attribute valid placement. So main.py line 54. Main.py line 54. Let's have a look. If button.is valid placement, okay. So at some point we are giving our button as being a string and it's not being what we want it to be. So if I come up to our computer, when we check the corners, our square equals grid row. Okay, that's fine. Find free space. If space.is blank, that's fine. Check for winning space. Return false, sure. Return blank 0. Return false. Return blank 0, blanks.append space. Yeah, okay. That all seems to be working. Blank 0, what are we appending? Blanks. Space. Interesting. So there's an issue here with the code. There is another bug. So what we're going to do is I'm going to take the time to kind of debug this because it's a really viable skill, and a lot of times I try and gloss over the bugs and kind of taking time to squash them, but I think it's worth us practicing finding errors in our code. So we've got an issue in our main.py function. in the clicked. So what I'm going to do is I'm just going to print button. Okay. So let's run this again. New session. Bob. Start this. And I'm going to go here. Okay, and you can see it's printing the button, each button that we're clicking. Now this is, you can see it's a gameboard.space object. So we made the space class, okay, and when we have an instance of the class, it's referred to as an object, and it says at 0x, and then it has this hexadecimal number. So that's where it's stored in RAM currently. It's just printing that out. Now, if I wanted more specific stuff, I could print out like button dot something, and if we go to the space class, I could say like button dot, what could I say? I don't know, size, and it would print out 8, right? Or button dot contents, and it would print out what's inside it. Or button dot, I don't know, whatever. But I'm just going to print out the button because apparently at some point in here it's printing out, it's giving a string, and we don't want it to be a string. So the computer's gone there. If I go down here, the computer's gone here. Now that's a really big problem actually. In turn 2, if I go first, I could win, and the computer's just not ready for that. So what I'd like to do is I would like, before we check if the other player did not go there, I want to check for a defending space. So I want to do this. Oh no, I don't want to cut it. Put it back. I want to take that and I want to put it up here. Okay, because the algorithm I took, the computer always has to go first. We're having to think about when the computer doesn't go first, and so here it's going to actually try and defend itself if it doesn't go first, which is really important because at the moment I'm like, boom, win. Okay, so let's restart this. Now it's got this little bit of logic in here. This should just work. I should just be able to copy and paste it in there and it should just work. Computer opponent, Bob. Let's start this. Okay. So I'm going to go here again, it's going to go there, I'm going to go down here, and you can see it's blocked me now, right? Because I told it to prioritize finding that defensive space. So that's fantastic, that's really good to see. And you can see there we've gone 4 times and we've clicked 4 buttons, and these are the 4 buttons we've clicked. Okay, so now down here, what do we want to do? I guess I'm going to go and try, okay, I'm going to snooker the computer now, right? So I'm going to go down here in the bottom right corner. It's defending again, which is good. That's fantastic, but I can still win. Sorry, computer. Okay, here we go. So, Nought, I'm going to go here. It goes there. That's really odd that it goes there. It really, in turn 2, it's looking for a defending space. Check for winning space. I think check for winning space is just slightly broken. Why is it broken? Why? What's it doing? I don't know. I don't know. Okay, it's going there anyway. I don't know why. Okay, we've gone here and, okay, it's broken. Look, attribute error. Oh, you can't see because it's behind me. Attribute error string object has no attribute. So if we come up, it should have printed that string. Okay, it's just an empty string. It's just an empty string. So instead of a button, where did I click? Down it. Oh, I think it might be the computer trying to take its turn. Lambda application.clicked self. Okay, self.next turn, self.turn, self.computer turn, self.clicked space, button.is valid placement equals true. So there's an issue with the clicked function in self.next turn. Let's have a look. Let's go back to the start here and let's see if we can find this and squash this, because this is just a really stupid little thing that's happening, and it would be nice to get this gone so our program just works. So next turn we change turn, we change the status of the players, and then we say self.turn. Turn, we just check to see whether the current turn is equal. If we are playing against a computer, we check to see whether the current turn is equal to our player symbol, and then if it is, we say computer turn. Okay, computer turn space equals self.players1.takeTurn self.gameboard.grid. So we pass in the grids to take turn on the computer class, and then we get a space returned to us, and we say self.clicked space. Now, it's really important then that when we try and run that clicked function, that we actually have a space. And what's happening at the moment is a string is getting through, and it's being passed there, and that's no good. So let's go first to the take turn. Okay, so we're saying square equals an empty string. Ooh! Square equals an empty string. So this is what's happening. None of these are running. It's not hitting these. And then it's just returning an empty string. Self.turns. Because we're not resetting the turns each time. So it's always on a rematch. Okay. Okay, fantastic. So what we've got here is we're keeping track of the turns that the computer is having, right? But it gets to like turn 5, and then we have a new game. But we've not reset how many turns the computer's had. And so it still thinks it's had 5 turns. And down here, if the computer's already had 5 turns, if it's like on its 6th turn, for instance, it's going to do all this. It's going to say, no, self.turns doesn't equal 1, 2, 3, 4, or 5. So I'm just going to return square, which starts as an empty string. Okay, so this is the issue. So what we need to do is we need like a reset, or we need like a new game function, right? And that's just going to reset all of our values. So I'm going to come up here, and I'm going to say def new game. And we are going to pass in the self, of course. And we are going to say self.turn. Oh, hello, caps lock. Self.turns. I'm so happy we squashed this. This is very satisfying. Oh no, I pressed F12. Self.turns equals 1. And self.turn history is equal to an empty array. And I think that's why it was going randomly in the middle, because it was on like turn 3 or 4 when it should have been on turn like 2, okay? Because we was jumping into new games and it wasn't resetting. So we've got this new game here. So when we restart a game in our main function, so down here somewhere, we do have a new game function. New game. So we need to say computer.newTurn, right? So actually, annoying. Let me close all this. Control K2. Let's close all of these. Let's come up to, where was it? 10. Computer turn? 10. If self.playerName, so if the player's a computer, we want this if line. Okay. So I'm going to come down here into new game. So if the game is over, then we can reset the board. Okay. So we're going to say if self.playernames1.get equals computer, we're then going to say self.playernames1.newGame. Self.playernames brackets 1.newGame. And this will run that method that we just wrote. And it will make the, oh, geez Louise, it will make the computer reset its internal stats. And so then it's kind of reset and ready to go. And if we wanted to add more to the computer and it had like more stuff to reset, we just have to chuck them into that method that we wrote in the computer. So new game function, and we know that that will just run every time there's a new game now. Okay, let's see if I can play 2 games with this computer without it crashing. And if we do, I'll be very, very happy. This is you've got to admit, like, this is very simple, but it's taken a lot more than you would have expected, right? And we've definitely not programmed it in the most efficient way, but it does work. Okay, this is broken, so let's run this again. Computer opponent. Oh wait, is running this... Is this okay? No, it's not okay. Why is it not okay? It's running into an error straight away. Computer opponent B. Okay. Self.playName string object has no attribute. New game. Oh, dingus. Sorry. So in our new game function in main, Okay, rather than, it's not player names, it's players. Sorry, variable names are too close together. So if the name of our player is computer, then we're going to say that player, the player class that is actually a computer class in this instance, should run the new game function. So that will just reset it. So now I should be able to do this. Okay, lovely. We're still printing this out. We don't need to be doing that. I can't quite remember where we put that though, which is a little bit awkward. Did I put it in clicked? Yeah, I did. Great. I can remember. Let's just get rid of that. And I'm just going to restart this once more. Okay, B. B for Bob. Okay, my turn first. So I'll go top left, it goes there. I'm going to go bottom left, and it should defend this. Yeah, it's defended it. Okay, now I'm going to go in the... where should I go? I know it's going to go in the corner, so I'm going to go in the corner. It goes down here. It didn't defend this. That's interesting. Okay, so it didn't actually defend the middle, so I can win. Fantastic. Rematch. So it started there. I'm going to go here. It goes there. I'm going to go here. It goes there. I'm going to go here. It beat me. Dang it. Okay, so it's actually working on the second go. Okay, so now I'm going to go. I'm going to go there. It goes there. I need to go there, and I beat it. Fantastic. So there is some kind of stupidity with the computer there, because it really should have gone and blocked me. Oh, I guess, did I force it into an impossible situation? That there. It won again. It's really good. So if I go here, here, yeah, okay, it can't win. Okay, I've outsmarted it. Which is fine. Which is fine. It's interesting that it's going in the middle though, and not in this corner. What's that? Turn 2. Turn 2. Let's just check turn 2. And let's go to turn 2. So it's looking for a defending space. It doesn't find it. It's then looking for an opposite corner. So I think it's this opposite corner that's throwing it off, right? So if coordinate equals 0, opposite corner dot append 2, else opposite corner dot append 0. Yeah, I feel like the turn history is just wrong somehow, and that's what's throwing it off. So row column. Although that's right. If that's 0, append 2. Otherwise, if it's not, append 0. So that gives us our opposite corner. Maybe what I'll do is I'll print opposite corner down here. Print opposite corner. And we will try and force this. So it's when I go first, I go top left, bottom right, bottom left. And let's see what it thinks the opposite corner is. So let's run this again. Debugging 101. It's a painful process, but if you get good at it, it's really, really valuable. Great, it's my go first. So I'm going to go there. Didn't do anything. It's not printed out anything. So let's try that again. Did I not put this in properly? Is this running turn 2? We are incrementing it by 1, right? Self.turns plus equals 1. Yeah, it's doing things. Turn 2, grid. Pass in the grid. Okay. Let's try it again. Compelling viewing, I know. Man sits in room and tries to tries to understand computer. Okay, let's let this win. Okay, now we're going to rematch. Go here. Okay, so it did print out 2-2 there. Go here. It should really be printing that out. Go here. We win. Rematch. Let's just clear the console. So I'll let it win again. 2-2. So it went there on that turn 2. I go here. Boom. Okay. But then when it's my go first, I go there, it goes there. I go here. On its turn 2, it doesn't print out that opposite corner, which is making me think that we know it's not getting there, don't we? We know it's not getting to this line. So that must mean it's returning a defending space. Because it's blocking me. Oh, okay, dingus. Okay, it's blocking. I'm being an idiot. It's actually cleverer than I give it credit for. Okay, it's working as it should. Fantastic. So we now have a Noughts and Crosses app that has some kind of competent AI in it. Okay, it's not an AI. It's not an AI, but it is able to kind of play this game against us. And it's won 2 games. Okay, I let it won, but it has legitimately won against me a few times where I didn't realise it was kind of playing against me. So we can kind of play against this, and it will play defensively. Oh, look, it beat me. It beat me. So this is really good. I have waffled on way too much, and I thank you for kind of bearing with me and getting through this. And hopefully you have enjoyed watching this and enjoyed programming along. I've tried to keep a good balance of like of what? I've tried to keep a good balance of keeping the pace on and not like lingering too much on something, but also not going so fast that it's hard to follow. Whether or not I've achieved that, I don't know. I'm gonna kind of call this the end, right? This is the end of where I'm gonna take you on this Noughts and Crosses journey. I was gonna do a little bit on high scores and a little bit on style, but essentially this has kind of gotten away from me a little bit. And what I would like to do is, if I was going to start looking at high scores and style, I'd refactor this code and change kind of how some of it is written, and maybe like tidy it up, maybe separate the Noughts and Crosses class into like 2 different classes, one for like the game and the state, and one for the actual application and the windows and things. Before I then started looking at style, and that would be a whole lot of admin to actually do those tasks. So what we're going to do instead is, for my next Let's Code, so next week I'll start a brand new one, and we're just going to start with a new project, and we're going to take what we've learned, start afresh, and we're going to do a new project. Okay, if you wanting to kind of crack on with this though, please do as much to this and take it as far as you like. Maybe you could think about how you would implement high scores and keep track of who's kind of got the most wins in this Noughts and Crosses. You know, like an old arcade machine kind of thing, where you get like kind of the 3-letter names print out with their high scores. Maybe you could do something like that. Maybe you could look at the style, maybe make the game board look a bit better, maybe make the stats area look a bit better. There is a whole library called tkinter.style, or I think it's TKS, something like that, that deals with styling Tkinter objects, so that you can have them not just this kind of very bland like font and background color. You can actually start changing it and making it look a lot better. So I encourage you to look into that if you're wanting to develop this further. If you never want to look at this again, I do not blame you. I'm kind of that opinion too. But what's really great is we have a working Noughts and Crosses game here. Okay, one thing that we never did is program this new session button. Maybe we'll do that really quickly right at the end. So we'll jump into main, and when we make this menu bar, so down here, what did we call it? Main menu bar, create drop-down menus. So down here we've got new session, and we're going to set the command to self.newSession equals self.new start new session. That's the one. So this should just really seamlessly slip in now, and ooh, it didn't like that. Didn't like that at all. Oh, okay, I've called it. I didn't want the brackets at the end. I just want the one closing bracket. My bad. So I should be able to press new session. We start a game. Okay, and then I can say new session, game, new session, and that does not do what I wanted it to do. What do I want it to do? I want it to go to the input screen, don't I? That's how we start a new session. So I want to say self.display input screen, not start new session. We need the input screen first to put the stuff in, then we press start, and that starts the new session. Okay, so stop that, let's run that. New session, Bob, computer, start, Okay, we have a go, and then I'm like, nah, new session. I don't want to go against computer. Let's go against Steve. And now I'm going to start this. Okay, and now it's Bob and Steve, and it's a classic human on human game rather than a computer game. So now we've kind of wrapped this up. Now you could program in your own commands and you could make your own screen. You could maybe make a rules screen, maybe a little credit screen that pops up and says programmed by so and so in 2021 when I had nothing better to do than watch this video. And you could kind of finish this off if you wanted to. I think that we've done enough programming on this to be happy with it. But if you want to take this further and really polish it off, then I encourage you to. As always, thank you so much for watching, for taking the time out of your life to program along with me and to work on developing an application. Hopefully you can see that like app development or like kind of any kind of software development is not just like a few lines of code, okay? There's a lot to think about, and some of the simple tasks can take a lot of time and can be made very complicated by certain people as well. And we will kind of look, as we go through these Let's Code series, we'll look at kind of shortcuts and ways of doing things more efficiently. But I think at this stage, it's probably better for me to do things in a kind of long, drawn-out way, and then slowly start to show you kind of optimizations so that you start appreciating why they are optimizations. Time for me to shut up. Have a lovely period of time until I see you next. And I hope to see you in the next Let's Code. Until then, take care.